Guys, if I say in a chemical reaction, atoms are not created and they are not destroyed, can I say, based on that concept, total number of atoms on the left, reactants, should be equal to total number of atoms on the right? That's simply is called balancing a chemical equation. It means if you are reacting aluminum with sulfur, and you get aluminum sulfide, and the formula of aluminum sulfide is Al2S3, I can't write chemical equation as this. Why? Because there are two atoms of aluminum on the right, one atom of aluminum on the left. That means number of atoms are increased. That means atoms are created in a chemical reaction. So what should I do to have two Al on both sides? Well, place the 2 here. Now we have 2 Al on both sides. So we balance a chemical reaction by placing a coefficient on the left-hand side of the substances. I cannot write Al2, but Al2 doesn't exist. That means we don't have a molecule with this structure. Al doesn't exist. So the number subscript shows the formula. We never change that. Coefficients are always on the left-hand side of an atom. So by placing a 2 on the left-hand side of Al, I have balanced number of aluminum on both sides. What about number of sulfurs? Look at the product, 3 sulfurs. Look at left. I must add a coefficient on the left of sulfur. So I have 3 sulfur on the left. Can I write S3? What is the meaning of S3? It means S and S and S are bonded together. This compound does not exist. So subscript determine the formula, determine the nature. And we do not change them. We balance the chemical equation by placing coefficient on the left-hand side. Are you with me? Any questions so far? Any question? All right. So this is reaction of ammonia. Excuse me for the noise of my chair. Remember, ammonia reacting with oxygen, making nitrogen monoxide and water. It's a chemical reaction which has been experimented, is happening. We write chemical reaction based on experimental results. We don't theorize and predict without experimental evidence. We experiment, we come up with rules and regulations. We understand the secret of universe. And then we use those laws. We don't arbitrarily combine atoms and come up with manufactured formula. It's based on real reactions and experimental evidence. So what are these red numbers? 4, 5, 4, 6. These are balancing coefficients on the left-hand side. How do you come up with? I'll show you later. We are not dealing with how do you balance a chemical equation. I just want to show that total number of atoms after you have balanced a chemical equation should be the same on both sides. Let's see if this is valid. Let's see if we have a balanced equation. Can I say I have got 4 times nitrogen, so 4 nitrogens on the left-hand side? How many hydrogen on the left-hand side? 4 times 3, what do we get? 4 times 3, is it 12 hydrogens? What else do I have on the reactant side, on the left-hand side? 5 times 2, 10 oxygens. So these are total number of atoms on the reactant side. Let's look at the product, then we can decide whether this chemical equation is balanced or not. In 4NO, we have 4 nitrogens, yes? And can I say 4 oxygens? Four oxygens in 4NO. Do we have 6 oxygens in 6 water? So can I say 4 plus 6 oxygen is 10 oxygens. That's total oxygen on the right-hand side. How about number of hydrogens? Can I say 6 times 2? 12 hydrogens. Is this equation balanced or not? Let's check. We started with 4 atoms of nitrogen. We ended up 4 atoms of nitrogen. 12 atoms of hydrogen. We ended up with 12 atoms of hydrogen. 10 oxygens. 10 oxygens. Yes, number of atoms are not changed in this chemical reaction. So atoms are not created or destroyed. So this is a balanced chemical equation. Number of atoms on both sides of a chemical equation must be the same. Any questions, guys? I love to hear a question and answer it. You know, make sure you're listening and you're understanding it. Any questions? Anybody? Okay, let's go to next. Can I ask you to do this? As I'm waiting, I want to see who gets the answers to A, B, and C the fastest. Go, guys. Wow, already 2 of you got it together at the same time. Good job. I need more people. Yes, keep going. Beautiful. That's very fast, good progress. Wow. Guys, do these make sense to you? Any questions, guys? Anybody has any question? All right. So guys, if you look at lead nitrate, this is lead nitrate. Do you see on the left-hand side, I have metallic lead. On the right-hand side, I have only non-metals. So can I say metals always have positive charge and non-metals have negative charge? In fact, nitrate is an ion. It has -1 charge, called nitrate. Remember, ions have charge. This is an ion Cl minus. It has -1 charge. And this is an ion with negative charge as well on the left. Do you see, this ion is made out of one atom, so I call this a monoatomic ion. Monoatomic. Nitrate is composed of 3 oxygens, 1 nitrogen, so can I call this a polyatomic ion? Polyatomic ions are ions which are composed of several atoms. So guys, you don't have to remember the charges and the structure of polyatomic ions. You get a table on the exam. You also have a table inside the book. Is it on page 89? Anybody? Give me the page number of polyatomic ions. Anybody? Open the book, give me the page number of polyatomic ions. When you want to find information, go to the index at the end of the book. They are alphabetically ordered. Look under poly, section P, find the page number, go to that page and let me know. That's how you find information in the book. Give me the page number. Who wants to give me the page number for the structure and charges of polyatomic ions? I'm waiting. Is it page 89? I want to see who can get it the fastest. Page 89.
It's 90.
90? Thank you, Alyssa. I know you're probably at work, so that's why you said 90. Are you at work?
Yeah, but I live at my work, so I'm just downstairs in my room.
Are you telling me you don't have a life? I'm teasing you, Alyssa. Yes, page 90, right? Do you see page 90? She's working and learning and all that. I'm so proud of you guys. When you struggle and fight against the odds in COVID-19, with fire, with electrical problem, with internet problem, having to homeschool your kids, having financial difficulties, yet you are not giving up. You fight back. I love you guys for being so strong. So guys, if you have a chemical reaction which contains a polyatomic ion like nitrate, if you want to balance a chemical reaction which contains polyatomic ions, look at them as a whole unit. That makes your life easier. That means if I see NO3, it's a polyatomic ion, I don't have to look at nitrogen and oxygen separately. I just look at NO3. I see there are 2 NO3 minus on the left. I need to place a 2 here to have 2 NO3 on the right. That makes your life easier. By placing these 2 in front of NaNO3, it means I have 2 Na, so I have to place a 2 in front of NaCl to have 2 Na on both sides. So 2 NaCl, 2 NaNO3. Let's see if reaction is balanced now. How many Na on the left? 2. How many Na plus on the right? 2. How many Cl on the left? 2 Cl minus. How many Cl minus on the right? 2. See, 2. How many lead on the left? 1 and 1. Balance. So this is a balanced equation now. So in balancing a chemical equation, you go back and forth, left and right, by trial and error. You introduce coefficients to have same number of atoms on both sides. And if you are dealing with polyatomic ions, just balance them as the whole unit. Polyatomic ions, they always act like a family. They never fall apart. They keep their own structure. They stick together. So it's easier to balance them as a whole unit rather than looking at number of atoms of polyatomic ions. Do you have any question, guys? Anybody? Any question? So if I go guys, please go ahead, do this. Let's see if you can get it. Let's see if you got it. In part A, you have three options. Are these correct? Which one of these is correct combination of coefficients? So I need coefficient here, and coefficient here. Which one of these? Option 1, 2, 3 shows the order of coefficient. Wow, 4 hands up. Beautiful. I love it, guys. Thank you. Wow, you are amazingly smart people. So guys, do this make sense to you? 3 magnesiums, oops, sorry. 3 magnesiums on the left, 3 magnesiums on the right, 2 nitrogens on the left, 2 nitrogens on the right. So this is a balanced equation. In part B, 2 aluminum and 2 aluminum balance each other. 3 times 2 is 6 Cl, and 2 times 3 is 6 Cl. They balance each other. So this is the correct answer. Do you have any question, guys? Do you have any question? Anybody?
Yeah, I have a question. Could you explain B and how you went about getting
Balancing?
that? Yeah, and how you balanced it, yeah.
Okay, you reacted Al and Cl2 to get AlCl3, right? So that was the question. So I have 3 Cl here. I can write 3 divided by 2. So 3 divided by 2 times 2. What is 3 divided by 2 times 2? Is it 3? It gives me 3 Cl, right? And I have 1 Al on the right and 1 Al on the left. So this is already balanced. Except we don't want to have fractional coefficient, or coefficients are supposed to be a whole number. How can I get a whole number from 3 over 2? Well, why don't I multiply both sides of the equation? The equation is going to be valid. So if I do that, do I get 2Al? And 2 times 3 over 2 is 2 times 3 over 2 equal to 3. So I get 3 Cl2, and I'm multiplying both sides by 2, 2 AlCl3. So that's what we got. So sometimes if you have to use fractional number, use fractional number, balance the equation, then multiply both sides of the equation by a number that you can get complete digits. That was a good question, Elvis.
Thank you.
Thank you, Elvis. Anybody else, guys? I want to thank you for attending the lecture. I can assure you that you will be rewarded. When you attend the lecture, you understand things much better than watching a video. I encourage you to attend lectures rather than looking at asynchronous recording. At least the ones that we do live, be there. Any other questions, guys? If you have any other questions, don't forget that in 12 minutes at 9:30, I'm going to start my office hour. The link to the Zoom is on Shasta Zoom. On your canvas, come and see me and talk to me, guys. Anybody else? Any questions? All right, thank you, guys. Have a wonderful day.